Good morning, sir, and good morning, classmates. Today, I will discuss the gene frequency and equilibrium. Gene frequency, the fraction or percentage of a population that carries allele. At a particular locus, it is also more appropriately known as allele frequency. So, with the use of gene frequency, we can able to find out allele into particular individual. So, this is the formula of gene frequency. So, gene frequency equals to number copies of an allele divide total number of all allele in locus. So, locus means fixed position kung asa ang chromosome. So, this is the locus na mano siya ang locus kani. Then sample, we have 200 individuals and the genotypic frequency is 120 mm. Mm means homozygous dominant, and 40 mn is heterogeneous. Then 40 NN is homozygous recessive. So M equals 120 times 2 plus 40 equals 200. Then 200 times 2 equals 400. Then to get the percentage is 200 divide 400 equals 0.7 or 70%. And to get the heterozygous recessive, N equals 40 times 2 plus 40 equals 120. Then 200 times 2 equals 400. Then 120 divide 400 equals 0.3 or 30%. To find the gene in the same locus, this is the individual, the vertical line. This is the different individual, and this is the locus, the horizontal line. Locus. So, gene frequency inside the population always remain in constant value if this thing follows gene frequency. No mutation, no selective mating, no selection, no migration, and no immigration. Gene pool. Gene pool is the total number of gene of population. So, this is the different individual outside the pool. Individual A, B, C, and D. So, this pool is the total number of gene of these people in population. Migration of population alters the gene pool. Alters means bag-o niya. Example, si A population entering to B population, this A population migrating, changing the B population. This picture, this is Godfrey Hardy and Wilhelm Weinberg. Hardy-Weinberg equilibrium. Under specific conditions, after one generation of random mating, gene and allele frequencies, gene pool, will be stable from generation to generation. Model system for population stability. In 1908, the Hardy-Weinberg law was formulated independently by Hardy, an English mathematician, and Wilhelm Weinberg, a German physician. They demonstrated that in the stable population, the frequency of the dominant and recessive alleles remain constant at whatever value applied to the previous generation. In the next slide, I will show you the short video about the allele frequency in a gene pool.
Hardy and Weinberg established a rule that enables us to calculate the frequency of alleles and their combinations in a gene pool. If a gene occurs in only one form, a homozygote marked AA, then it will be present in every genotype. Its frequency, represented by a small p, is 1, or in other words, 100%. The frequency of the genotype AA is shown by the equation p squared equals 1. If a gene has two alleles, A1 and A2, the diploid individual resulting from the fusion of two haploid gametes can have one of three sets of these alleles, A1A1, A1A2, or A2A2. If P is the frequency of allele A1 and Q is the frequency of allele A2, then the frequencies of both alleles are shown by the equation P plus Q squared equals P squared plus 2PQ plus Q squared equals 1, where P squared is the frequency of the combinations of alleles A1A1, 2PQ is the frequency of the combination of alleles A1A2, and Q squared is the frequency of the combinations of alleles A2A2.
This is the end of my report, and my co-reporter will continue this topic. Thank you.
Complete dominance. Complete dominance is a condition wherein the dominant allele completely masks the effect of the recessive allele. Consequently, both alleles must be recessive for the recessive allele to be expressed. 6 linked alleles. 6 linked as related to genetics refers to characteristics or traits that are influenced by genes carried on the 6 chromosomes. In humans, the term often refers to traits or disorders influenced by genes on the X chromosomes, as it contains many more genes than the smaller Y chromosomes. Males who have only a single copy of the X chromosome are more likely to be affected by a 6-link disorder than females who have 2 copies in females. The presence of a second non-mutated copy may cause different, milder, or no symptoms of a 6-link disorder. Multiple alleles. Multiple alleles exist in a population when there are many variations of a gene present. In organisms with 2 copies of every gene, also known as a diploid organisms, each organism has the ability to express 2 alleles at the same time. They can be the same allele, which is called a homozygous genotype. Changes in gene frequency. Changes in the population are in reality changes in gene frequencies. These changes are the elementary processes of evolution. The changes in gene frequencies may be affected by mutation, selection, migration, and genetic drift. Mutation. A mutation is the phenomenon of alterations in the DNA sequence or chromosomal arrangement. The mutation alters the genetic message carried by a gene. It results in the development of new characteristics that are capable of being inherited. It results either due to an error during DNA replication or damage to DNA.